Petrol is explosive, not as explosive as diesel, but petrol is explosive. We can all agree to that. So, if this explosion can be put into an environment that is controlled, that explosion can do work. Work is just force times movement, okay? So, we have petrol that is explosive. If ignited, petrol becomes explosive. And so, if this explosion can be put into a contained environment, it can actually produce force. This force is what is used to drive vehicles. So in this video, I want us to look at how a vehicle works. So we'll start with the basics of a motor vehicle, and we'll go all the way into the modernization era. So we'll start with the basics. Then we'll go into the modern era. Okay? Now, the basics of a vehicle includes igniting petrol, so let us stick to petrol engines so that we make the video to be simplistic. Okay? So it consists of igniting petrol, then you generate the explosion, then this explosion will push metal components. We look at them, and these metal components will generate this explosion to become a rotary movement, and then this one is transmitted to the wheels. So let us break down this petrol engine into various components or various systems. So number one, we have the fuel system. Then you come to the ignition system. And the ignition system is broadly classified as the electrical system. Okay? Then you now come to this rotary movement, which is now the transmission system. The transmission system. And then, because this fuel is generating heat, you will have the cooling system. And because these metal components are moving, you have the lubrication system. Okay? So basically, you can break down a vehicle into these various systems. Fuel system, which includes fuel system, the electrical system, which includes the ignition system, the transmission system, cooling system, and the lubrication system. So, I want us to look at what every motor vehicle that runs on petrol has. These basics. You have fuel that gets into a cylinder, and then there is the compression, and then the fuel is ignited by a spark plug. Once it is ignited, there is the explosion that generates a downforce movement on the piston, which is called the power. And then you have the power going to the transmission. Okay? We are together up to that point. Basically, the cylinder, this is what is basic for all motor vehicles. Now, you have the engine block. The engine block consists of a number of cylinders. Okay? So, we will draw basically the cylinder to be this way. Okay? And you have the piston inside. Okay? And then you have that pin over there. Okay? And then you have the push rod. Then the push rod goes to the crankshaft. Okay? And on top here, what do you have? You have a spark plug. Okay? Then what else do you have? You have valves. We are together up to that point. So that these are valves. This is the piston. This is the cylinder. This is we name this part inside here to be the crank shaft. This is the connecting rod. And this is the spark plug. Okay? So, how does a vehicle start? You have a battery and a starter. The battery supplies power to the starter. The starter rotates the engine, so it rotates the crankshaft, which makes the piston to go up and down. Okay, that movement. When the piston goes down, fuel enters through the intake valve. Let us call this the intake, and let us call this the exhaust. Okay, there is also a different setup that will have an injector. Okay, so we'll discuss that as well. So in the vehicles that have what is called a port injection, when the piston moves down, because it is being rotated by the starter, fuel is already injected into the intake valve. Fuel plus air rush into the cylinder wall, okay, rush into the cylinder. And then when the piston reaches the bottom level, which is called the bottom dead center, okay, the cylinder has already filled with air and fuel mixture. And now the piston starts moving upwards. When it starts moving upwards, this valve closes and this valve closes. So it makes an airtight container. Okay, so as the piston is moving upwards, it compresses the air and fuel mixture. When you compress something, when you compress air, you increase the pressure, but you also generate heat. Okay, so when the compression is just enough, the spark plug will release a spark. Okay, and therefore this air to fuel mixture will ignite. It will generate an explosion. The explosion will push the piston downwards, and thereby creating that rotary movement in the crankshaft that is transmitted onto the wheels through the transmission system. So it is very simple. So once that one has started and ignition has already taken place, you have already created that power through the crankshaft. Then all the other systems wake up, okay, and now the function of the starter now is done, and now the vehicle now starts running on its own. Okay, so from that simple illustration, it means that we have several components or we have several movements of the piston. Okay, so the first movement, which is downwards, which will come out from the top dead center to the bottom dead center, the first movement will be the intake, where air and fuel mixture will rush through the intake valve into the cylinder. Okay, then the valves will close and the piston will start moving upwards, and it will start moving upwards through what is called the compression. And then when the piston reaches at some point, when it has compressed the air and fuel mixture up to the desired pressures, ignition takes place through the spark plug. An explosion is generated and the piston is forced downwards through the power stroke. Okay, and now because it has ignited and it has generated now the waste and the soot, the piston will move upwards. This exhaust valve will begin to open as the piston is moving upwards, and therefore it will expel the waste gases, which will now translate into becoming the exhaust gases. And so that movement upwards of the piston now becomes the exhaust stroke. So there are 1, 2, 3, 4 strokes of the piston. So this one is called a 4-stroke engine. Okay, so this one now becomes the 4-stroke engine. Okay, and this particular setup of mine has 2 valves, okay, per cylinder, which is a setup that most vehicles have, almost like I would say like 50%, but also 50% of them also have 4 valves, so that each stroke has its own separate valve. So this setup that you are seeing here, this is the setup that every vehicle has. This is what is contained in the engine block. Okay, so it will have that component. Those components, the cylinder, the piston, the connecting rod, the crankshaft, and of course we'll have our top cover, which is now called the engine cover. Okay, so this was the basic by which most engines were running on. Okay, so what modifications took place over time? Now we look at the modifications that have been taking place over time, and we look at them from the systems, from the systems as we had described earlier. Number one, in the fuel system, what modification or what advancement has taken place? Number one, nowadays we have high octane fuels, and these high octane fuels, they give more power per quantity of fuel than what was being used back in the day, and they have less emissions, they have less lead, and lead is cancerous, and they have that high power output. Okay, another modification that has happened is that we've seen direct injection coming into play. This system that I've described here, it is called a port injection. But then there is a direct injection whereby only air rushes into the intake valve, air without fuel. Then the piston comes up and compresses air. Once the desired pressures have been achieved, a quantity of fuel is injected through fuel injectors at the top of the cylinder. And because that fuel is being injected into hot air, it ignites spontaneously. Okay? So, but then the ignition is also being assisted by the spark plug, such that you find the ignition, the injection of the fuel and the ignition of the spark plug are also more like running at the same time. Okay, so there is that direct injection, and because because the fuel is being injected into the cylinder that has already developed high pressures, this direct injection uses high pressure fuel pump and also uses the injector nozzles. So those are things that are coming up in the newer vehicles. Okay, fine. So that is about the fuel system. So let us look at the exhaust system. What other modifications have happened? We look at the exhaust system. Now, it was discovered that as the exhaust gases are leaving the engine or are leaving the cylinder, these exhaust gases have some properties, and some properties were discovered to be beneficial. For example, let us look at it. Exhaust systems comes at a pressure because it is being pushed out of the engine by the piston. This pressure was harvested, and it can run a turbine. These exhaust gases can run a turbine, can go in and out and generate a turning motion of a turbine. And this turning motion was made useful because on the other end, it can also turn another turbine that can assist in injecting air into the intake. And this is what is called a turbocharger. So the exhaust gas goes through a pipe. The pipe terminates into a turbine. It turns the turbine. The turbine on the other end also runs. This turbine turns and also turns another turbine that is connected to the inlet. So it sucks in air and takes this air with pressure into the intake. So then we had now the advent of turbochargers from the exhaust system. And there was also another discovery that even as the exhaust gases are leaving, they are leaving with some unburned gases. These gases were discovered that they can be recycled back into the intake, okay, and recycled back into the exhaust gas regulator, which is the EGR valve. And this is one common area where a lot of soot occurs because of generally soot being accumulated over time, and also because of dirty fuel, and becomes problematic. Okay, so as the exhaust gases are almost leaving the car, they are also discovered that these exhaust gases, they are harmful to the environment. Harmful to the environment. How? They affect the ozone layer, thereby causing a degradation. When the ozone layer becomes degraded, we have now a phenomenon called global warming, which is a threat to the planet. Okay? So, another thing that also discovered is that these harmful gases also become harmful to living creatures, including humans, causing cancers and other respiratory conditions. So we have cancers and other respiratory issues. Okay? So to limit these harmful gases going into the environment, they did add something else here just before it leaves. For diesel engines, called a diesel particulate filter, and for petrol engines, called a catalytic converter. Now, these two things, when dirty fuel is used because of the accumulation of soot, because of unburnt gases, they can get clogged and they can present with issues in the running of the engine. Okay? Now, let us look at another system that we did not really focus on last time when we were looking at the systems, and that is the air intake system. Initially, it was just a straight system into the engine block through the valve. Okay, it was just straight into the engine block through the valve. But then, with the advent of computers and the involvement of computers into vehicles, a valve was placed just right after the air cleaner, called a mass airflow sensor. So this mass airflow sensor detects how much air is rushing into the engine, and takes this data and communicates with the ECU of the engine and tells the engine how much fuel to inject. So that's one of the modifications that was done. Okay, then as we are speaking about the modifications that have been happening over time, we have other sensors that were incorporated into the engine. Okay, about 10 to 12 sensors. You find about 10 sensors in one car. Okay, but also depending with how sophisticated the car is. But then we had the advent of the sensors, and we have mentioned several, but there are others like the crank position sensors that not discussed about, fuel level sensors, oil level sensors, and all those other sensors that you will come across. So that is basically how an engine works and how a petrol engine works specifically. Very simple, okay? But with the advent and as our technology has been advancing, we've been seeing more and more things being brought into the simplicity of the petrol engines and simplicity of the diesel engines, making it almost becoming a complicated system to understand. But these are the basics. We'll continue digging deeper into this engine and exploring each thing bit by bit in trying to see what is happening in the world today. And for this and more informative content, please do not forget to subscribe.